All right, folks. Welcome back. This was a surprise. I was not expecting that over 1,000 of you would have watched my little video about Star Citizen's craft database woes. So thank you. Uh, Very much appreciated. Thank you mostly for your kind comments, and I do think that I have fixed the audio issue. I was like putting this up on my personal channel. No one is going to watch this, and so I just kind of yeeted it onto YouTube, hit the publish button, went to bed after recording it without listening to it. And by the time I woke up the next morning, on the one hand, it had 200 views and several comments and growing, and on the other hand, I was like, oh god, what's going on with the audio? What's happening here? I'm so sorry. So, I think I fixed that, and I will listen to this before I post it. But also, it's 1 a.m., and I'm not getting paid to do this. I just am obsessed with this game to a potentially unhealthy degree, and enjoy sharing this insight with you all. So, several folks asked me to do a video about the server meshing, persistent entity streaming, replication layer presentation at CitizenCon 2953, this year's CitizenCon, which I was not able to make. My life exploded the week of it, and I just, did not happen. So that was a disappointment. The flip side is I'm not actually sure that any of the people I wanted to talk to were going to be there. I realized in retrospect that the back-end people don't tend to get let out for good behavior. So, speaking from personal experience, yeah. You're over here. I'm sorry. My OBS window was on the other side. Also, my housemates are making, I don't know, a midnight snack in the background, and I apologize about that too. Maybe I'll edit this out. My problem is that I make the perfect the enemy of the good, and so if I try to do this with good production values, I'll just never ship it. And I just have to accept that there's going to be the sound of them clanking around in the background, and I'm recording this at 1 a.m, and it is what it is. So yeah. But where was I going with this? So yes, I didn't make it to CitizenCon. I'm not sure that people were there. It's an interesting presentation. People were like, oh, will you do a thing about the CitizenCon presentation? And at first I was like, I don't know if I really have useful things to say about it. And then I was like, oh, but there was that thing that my friend did back in 2006 about distributed systems and games and what he had learned from his LARP experience, live action role playing, lightning bolt. Friends of mine, by the way. Yeah, that's the kind of nerd that I am. And I was like, oh shit, I do have useful things to say about this. So here I am, attempting to say useful things, but I don't feel like I have them in as structured a way as I did that for the last one. So I'm going to do this as a more traditional React video. I've also learned just enough OBS Studio to be dangerous in the last month. So you get my best attempt at that, and we're going to do this. I'll do a light edit on it, make sure that the audio isn't complete crap, and I will then yeet it up onto YouTube without trying too much to make it pretty. And I don't know. I hope you enjoy. Let's kick it off. See? Transitions. You're over here now. There we go. Okay. So we're at 1 hour and 15 minutes into the CitizenCon 2953 Shaping the Verse, the Future of StarEngine presentation, which was the first thing they did. And if you haven't watched this, go watch the first hour and 15 minutes of it, because it is really cool. They've taken CryEngine, the Crisis engine, and they've made it their own. I don't know, they sorted out the trademark issues with Amazon, who were trying to make it Lumberyard for a while. Crytek went through some kind of bankruptcy. I have just to sort of like level set, gone and re-watched the presentation from a couple of years ago about the persistent entity streaming replication layer graph database server meshing stuff. And I have also gone and I'm going to turn the monitoring off. I'm sorry, listening to my housemates make popcorn in the background is just driving me nuts. I've also gone and rewatched my video that I did, so I think that I remember about 80% of what I said, and so I'll try to only repeat the important and or interesting bits. But yeah, let's kick off.
Right. Hello, everyone.
Goodness, is that too loud?
So,
That might be too loud.
persistent entity streaming,
Sorry about that.
replication
Let me bring it
layer,
down
and
a
beyond.
notch.
My name is Paul Reindel. I'm Director for Online Technology. And I'm going to show you a little bit insight in our technology for persistent entity streaming and the replication layer. I thought about what's the best way to show you something about that tech, and I thought about putting some technical drawings on the slides, or maybe show video like we did 2 years ago. But really, the best way to show you how persistent entity streaming works is to give you a live demonstration. And that's what I'm going to do.
All right. So there are two schools of thought about live demos, and they're both correct. One is that there's the Arthur C. Clarke quote about any sufficiently advanced technology being indistinguishable from magic, and the real thing that's indistinguishable from magic is a rigged demo, which any live demo is. And the other line from software is, don't do live demos because they always fail. You will always have bugs. CIG seemed to do a pretty good job of avoiding the bugs in their live demos, which may suggest something about how rigged they were. But nevertheless, bravo to them for being brave enough to do this. They did seem to do a real nice job, and so, yeah.
All right. So this will all be live, so please bear with me if there's any glitches.
Live here also means, I assume, that it's running on, his laptop or a server under the lectern, or at worst back in the, production booth, and not, live the way it will be on the live servers when all 100, 150 of us are connecting to a game. So just FYI there.
So let's keep this rolling. I think I'm supposed to press the button. No, it's already switched. Before we start, a little bit, I just give you a little bit an overview what you see here. Let me set up everything.
Another disadvantage of live demos. But how do you know it's live?
One moment, sorry. So on this left side, you will see my client window. And on the bottom side, you will see the server renderer. So for this demonstration, and I start a second client, I'm just stopping that. Sorry about that.
The best part of live demos is the waiting.
This is live, all right. So again, on this side, you see the client. And he just logged out because I started a second client. So let's do this again. One more time.
Like I said.
On this side, you see the server renderer, which is currently, it has nothing streamed in. I'm showing a small demonstration level. And on this side, you see the entity graph, which is our online database. That's powering what you see in persistent entity streaming, what you play since 3.18.
Sorry if you hear my housemates making a late night snack in the background. That's, yeah. Yeah, that's what it is.
And I also have some metrics on the screen which shows the entity graph worker, the requests per minute, per second, the mutations, and you also will see entities created and destroyed once I do that. All right, so let's wait for my client to come up and join this level. So the first thing that will happen when I join this level, you will see on that server, everything streams in, and my client gets connected and also streams in everything on the client view. What would happen on the behind the scenes is that my player just got unstowed into that shard, and we at real time created everything for this player. So you will see his body is attached to the player. You will see his mobi-glass, his head with all his customizations, his undersuit, and then all his customizations as well on the undersuit. What you also see is that this player just got unstowed and attached to a static zone object container. And this is how our zone system works. Basically, on the server, you will see 3 different zones, purple, green, and red. And each zone comes with its own coordinate system and its own physical grid. And this is how we actually, on live, do zone transitions between your ship, empty space, space station, or a planet. And you will see, as I walk between those zones, I will, at real time, update it in that entity graph. And this all happens seamless. So for a client, this is completely transparent. You don't notice that. But this is actually what's happening when you step in or out into a ship. And this is very unique to our engine. No other engine has this zone system. And that allows us to do all the amazing stuff you saw in the videos before, transitioning in and out of planets and go from the smallest scope to the largest scope.
So I think in the last video I talked about how, the strength of the graph database model that CIG is using here is that it's what we call in computer science an atomic operation, meaning that it's indivisible. It is you cannot get stuck in an intermediate state to move the edge of a node, the parent of a node, from one parent node in the graph to another parent node. So there was at least one comment on the last video, which is like, is it possible that half your ship would get stuck on one side of a Stargate and half your ship will get stuck on the other side of a Stargate? And the answer is hopefully no. And there's a lot of big ifs here, it should not be possible to get half your ship stuck on one side of a Stargate and half the ship stuck on the other side of the Stargate, because your ship, the parent node of your ship, is just one node, and so it's a simple, it's a pretty simple operation inside the memory of the computer. It should be an atomic operation, or an operation that we can make atomic inside the memory of the computer to swap the parent node from one node to another. So that is, I believe, in an ideal world, what's going on here. But now the interesting thing is that it's being used here for sort of arbitrary volumes of space, right? I said in the last video, I think that one of the nice things about the sort of solar system model that CIG has is that it's very unlikely, for example, that, something at, Microtech would interact with something at Hurston, because they're so far away spatially in the simulation of the game world that, and there aren't any sort of Ansible mechanisms or whatever we want to call it. The only way you can interact with something at Hurston from Microtech is to go from Microtech to Hurston, right? And they introduce a lot of delay, this is... So what's interesting here is that abstraction, that things in one region of the game world, or that they are using this abstraction of object container as sort of an arbitrary, abstract region of space, like they say, with its own coordinate system, its own frame of reference. They're using that for spatially, again, in the simulation of the game world, much smaller volumes, which are much more which share much more surface area in common. So here we've got what looks like call that, I don't know, scale is a little hard, but let's assume that this box over here is maybe about a meter square, And this box from the player's viewpoint is probably like over here. So like, let's assume that's a meter. So we're talking, I don't know, just eyeballing this. Let's probably not 100 meters. Might be like 50 meters. Does that seem? Because if we call this 10 meters, then this is another 10 meters, then this is another 10 meters. Call it 40 meters. I don't know. Just like ballpark rough numbers. Again, all in the simulation. Let's say that this region is maybe 40. Call it 40 square meters. Or 40 meters on a side rather. And then each of these regions are maybe 20 meters on a side, just like ballpark. So like that means that the interface between these regions over here is, 20 meters. Regions over here is 20 meters. You have to deal with anything entering the volume via this manifold, basically via this, anything that goes through this rectangle in space, you have to transition from the one to the other. So this is going to come up later, I suspect. And the first thing that I noticed when I saw this is like, note how hard it is note how there's this L shape. There's this there's this dog leg. It is very, very hard for something to go from this region, the purple region, to the red region quickly. It has to go like here, it has to change direction. So like maybe you can make a bank shot, like, and it would be a tight bank shot, from this corner, if there weren't these boxes here, like over here, here, into this. Like, imagine if this was just a straight shot. I suspect that this will be relevant due to the server tick rate. Again, we'll get to this in a minute. But like, this was just like the very first thing I noticed when they put this up. I'm like, oh, okay. They're having to do some. They have made some choices here to limit how much things can interact if they are not in adjacent regions. They've made it really, really. You really, really have to get into this region and stay here for a while. This middle region, before you can go. If you're coming from one of these end regions, before you can go to the other region. Like, it is very, very hard for you to be moving fast enough that you can go across this middle region before the server has time to think about it. So like, I suspect that tells us some things about their architecture under the hood. But anyway, let's get back to Benoit.
Everything we do in a shard, so this is like a mini level, like the mini PU level, is also persisted in this database. When we create...
Oh, that was the other thing. So he talked early on about the player getting unstowed from... And this is a thing that also came up in the very first persistence talk, where they were like, okay, so we have the global sort of graph database, which is the thing I was talking about in the last video, where I'm like, I don't know of anybody who's using a graph database as their like main source of truth, doing like transactional workloads on top of it. And then they've got this replication layer underneath that. And so I thought naively, maybe the replication layer's job is just to store sort of the properties of the nodes. Any sort of, in Neo4j, this is modeled as a key value pair, which can be, but you can attach arbitrary data to nodes, right? Like, as much as you want. It can be, text, it can be numbers, it can be images, it can be, other, nested structured data. It can be really whatever you want. But the thing that the graph database primarily cares about and is primarily optimized around making really fast and doing really fast queries on is the sort of graph queries. Like, how do I get from point A to point B in this structure? What is the shortest path from point A to point B? These kinds of questions. How many inbound edges does this node share in common with the outbound edges of this node? Or how many inbound edges do these two nodes share in common? All these kinds of queries about the graph structure, which is also not guaranteed to obey any particular sort of like, some graphs, simpler graphs, we will simplify a graph by saying it must be directed. Nodes can only, you can't have loops in the graph, for example, but like many real world graphs have loops in them, and so we have to cope with that, which makes things more complicated. So my naive thought had been that maybe the persistent, or maybe the replication layer was going to cache all of the property, all of the sort of key value pairs on the nodes, but let the high level graph database sort of handle all of the relationships between the nodes. And no, that doesn't seem to be what's happening here. The persistence layer is, or the replication layer is actually just like what we would call a write replica of the main graph database. It's really just letting them have multiple copies of the same graph database cached sort of closer to the game servers, which makes sense. That's another way that we solve these kinds of problems in more traditional database workloads. We'll also sometimes have read replicas. Like, it depends a lot on whether the workloads that we are trying to optimize for, whether the problem that we're trying to solve is very write heavy, meaning that we're writing a lot of data to the database, but we're not reading it often, or whether the workload that we have is very read heavy, meaning we're reading it often and we write to it very rarely, relatively speaking. And so, it seems that what we have here, again, sort of like the talk that I did with Zachery Johnson, the guy who had worked at Blizzard Entertainment on Diablo 2, Resurrected, is a very write-heavy workload, and so we're doing all of these writes to a full version of the graph database, which is local to the game server. This is that replication layer, and then eventually those writes will get persisted back to the global graph database, and also that it's the full graph database, or it's the relevant bits of the full graph database, the bits of the graph database which are relevant to this particular game server, meaning the player, everything the player interacts with, the player ships, as well as sort of like the things that are in every instance of the game world, all of the planets and systems and stations, but not players, the information of players who are not on that game server unless they've like left a ship lying crashed on a moon, for example. So yeah, it is a full, like, they're doing all the same things that we might do with a traditional table structured database like MySQL, with write replicas, again, very much like Zachery Johnson described about the Blizzard architecture, but they're doing it with a graph database instead of a table structured database, which is, again, I don't know anybody else who's using a graph database this way, and that's a brave choice.
New entities in our engine, in StarEngine, those entities, new level, is also persisted in this database.
Right.
When we create new entities in our engine, in StarEngine, those entities get pushed into our entity graph, into our online database at real time, and then from there replicated to our clients. So
that's right. The entity graph is the thing they call the global persistence database, and the replication layer are the cached local write copies of the entity graph that are kept local or more local to the game servers.
If I go ahead and spawn a couple of plushies here, you will see they spawn, they get created immediately on my entity graph,
right,
and replicated on the server and on the client.
Right.
Spawn a couple more here.
Now there's an interesting question. I don't believe that the client is running Neo4j. I think that when they say replicated on the client, they mean replicated in the graph structure that the game engine keeps in memory, which is a different kind of graph structure. It amounts, like, think of it as it's an in-memory graph database rather than a sort of graph database with any kind of persistent storage, and probably very different structures. But like I said in the last video, as far as I understand it, with zero game development background, game engines really think in graph structures. That's their sort of like native representation of the world, and so it makes a lot of sense to store this data on the server in a graph structure, because then you don't have to do any translation to get it into the game engine, or you don't have to do too much translation. You don't have to take it from a table structure to a graph structure. However, graphs are really, really hard for computers. I talked about cache locality as one of the problems of them. And so that's why we tend to simplify our problems into things that are table structured, into things that computers are better at dealing with. And CIG have chosen not to go that route. And, again, it seems to be working okay so far. But it is a choice that, as far as I can tell, nobody has tried to make before. And so it does not surprise me that they're hitting some growing pains. And so in here, these plushes, it looks like, are getting spawned by the game client, which both like creates them in the in-memory graph structures that the game engine has, as well as sends a message to the game server, in this case the replication layer of the game server, and is like, okay, create these plushes, spawn them in these locations. And eventually, my understanding is, like, when this instance of the game server gets destroyed, the game server will persist its state back to the entity graph, the global long-term persistent graph database storage. That is a bold move. If the game server crashes and for whatever reason, that corrupts the replication layer, and the replication layer cannot persist that information back, that information is just gone. Those plushes that you spawned have just vanished into entropy. But that is my understanding of the way that they are thinking about how this is going to work.
Yeah. And you see this, the pengus I spawn in the other zone get attached to the other zone. And then if I go and transition one of those, they will also transition between the different zones. And the same works for ships.
So this is the hard part. He just said that, did that like it was nothing, but this is the hard part. As far as I can tell, this is all happening on a single server, and it's not clear to me from this demo yet, at least. Maybe it'll be clear if I stop talking in like 10 minutes, who has authority for what here, but the fundamental problem of distributed systems is something called the distributed lock problem, where it was the first thing we implemented in my distributed systems class in college anyway. And it is really just like ensuring that only one, you've got, let's say, 3 computers, 3 servers, distributed file system. It's ensuring that only one computer can ever have a file open for writing at the same time. Only one of these servers can ever have a file open for writing at the same time. And we do this by having a distributed lock service, whose sole purpose is to be like, this server has the lock for this file and is the only server that can write to it. And all the other servers are supposed to check the distributed lock service and make sure that nobody else has claimed this file before they try to write to it. And if somebody else has claimed the file, they're supposed to either like throw an error to the user or just block, and we call it block, wait until the other computer has relinquished control of the file. And if you've ever used like a shared drive in Windows, you've probably encountered this, like, somebody else has this file open, you can't open it, or somebody else has a file open on this drive, you can't unmount the drive, this kind of thing. Like I said, fundamental problem of distributed systems. And it's a hard problem. It's a really hard problem. It was the first third of the distributed systems class that I took, and if you had any bugs in your distributed lock service, you were not going to complete the course successfully, because it was foundational to everything else we were going to build. And at the time, they had us implement an algorithm called Paxos, which I don't know if Raft was around yet. These like, distributed consensus protocol is the name for a lot of this stuff. It's the best paper explaining Paxos is written by this guy Leslie Lamport, also the author of the Law Bits of LaTeX, if you're familiar with it. That's neither here nor there, but it is written as a dialogue between Greek philosophers whose names are all the transliterated names of like famous computer scientists. So, like one of them is Liskov, after Barbara Liskov, and I forget the rest. That's the best academic paper on this. It's called Paxos Made Ridiculously Simple or something. It does not make Paxos ridiculously simple. Leslie Lamport is a troll. Everything about this was terrible. I did eventually get my distributed lock system working, but it taught me a lot about distributed systems very quickly. You do not want to build a distributed lock system. CIG have somewhere in here a distributed lock system. You can, again, in that video with Zachery Johnson that I did on the other channel, you can hear him talk about what happens when your distributed lock system breaks. In that case, it broke that you couldn't release locks anymore, so nobody could get locks, and the whole system just ground to a halt. That is actually the preferable outcome, generally speaking, because the other outcome is that everybody can grab the same lock and then stomp all over each other, and your system grinds to a halt in a very different and much more, shall we say, fireworky kind of way. Yeah. Distributed systems are hard, man. Distributed systems are real hard.
Or more complex entities. If I spawn this buggy here, you will see this one gets created with all its attachments and everything else attached to it. And this is just my small demo level here. On live, we have up to 600,000 dynamic entities that get created for one single shard. And this is just the initial state. After 2 weeks, 3 weeks of gameplay, when you guys go in and destroy stuff, spawn stuff, play around, it goes in the millions of entities.
Yeah.
So this in itself is pretty...
It's not actually a large graph, but it's a large graph to be dealing with in real time in this kind of fashion. Like, I don't know how many trillion web pages there are on the internet now, which Google deals with, but Google deals with this, like, overnight. They can throw an entire data center's worth of compute at this, and like they have a bunch of stuff that they do in real time, but there's also a bunch of stuff that happens in like big batch jobs. And so like here we have millions of entities that need to update all of them in near real time. So that is what makes it's not the size of the graph that makes this problem hard. It's the size of the graph relative to the relative to the tick rate, relative to the cadence of updates that matters.
Pretty amazing tech. The next time I want to talk about is our streaming system. Most engines do stream on texture or geometry. We actually stream entities, and we do stream persistent entities. So when I turn on the streaming system here and I walk into this, if I walk over to the red area, you will see that the purple area will stream out together with all the entities on that server. So it does not only stream out on my client, it actually streams out on that server.
So they're actually doing some of what we might call garbage collection on the server memory, which is, I have no idea how like densely packed they intend these zones to be on the servers, or like they may still not have figured that out yet, but it is at least like an important and useful thing for them to have figured out that like, oh yeah, okay, we can say there are no players currently active in this object container. We can persist anything that we need to persist from this, and then we can free up the memory. I don't know what their memory pressure is like on these, either in the game client, either in the replication layer, or in the game servers, which are doing sort of all the physics calculations. But My impression is that it's not like an enormous amount of memory pressure, but I could be wrong on that, and that's also relative to like what, I don't know. You can toss, hundreds of gigabytes of memory into a big Threadly like AMD EPYC kind of server for certain kinds of workloads, but that's probably not what they're using here. And so it's all relative to like how much they're like, the processes of whatever, service this is can access quickly. But what I infer from this is that there are some sort of limitations around how much memory they have access to, how much memory they want to keep around on any given basis, and so being able to sort of like stream out bits of this is useful. That's very common, at least on the client side, in game engines. If you've watched any of the Digital Foundry content, they talk a lot about texture streaming and geometry streaming.
And when I come back in the green zone, that purple zone streams back in with all the entities in there with their full persistent state.
Where does that get streamed back in from? Good question.
So now I have a second player joined. Benoit is going to join me. So Ben, if you want to join, okay, I think you see him over there. Hey Ben. Sorry. Nice. All right, I'm going to spawn a couple more penguins here. Because the next thing I want to talk about is new technology we are right now developing, and we are about to put on the tech preview for you to play. And this is actually the replication layer split. And that's the big next step in our great vision, obviously, as you might know. So in this demo, my client and my servers, they are no longer directly connected. Actually, I have a new service running here, and that is our replication service.
Oh, okay. So I got a little bit ahead of him. I have been talking about this like the replication layer is in place, and in fact it has been, but like what he's been describing has been from a perspective where before the replication layer wasn't in place.
So my client is connected to this replication service, right, and my server is connected to this replication service.
Right.
And the replication service, the sole purpose is to get all the entities which are in the entity graph and stream them to clients and servers which are connected to.
Right. This is that write cache I was talking about, where it's letting the game servers write to something that's much closer to them and dedicated to them, and then eventually that information will persist back to the global entity graph.
And what's really cool about this is, let's do a little experiment here. You all know our game has bugs. It's still alpha, and
everything
sometimes
has bugs, darling.
Things can happen. So let's see what's happening when I kill my server here. So this is my server, the actual console. So let's just shut it down.
Whoops.
And yes, this is where you would usually see a 30K or something.
Yeah.
You can see Benoit kind of froze there for a bit.
Not great if you got somebody trying.
I can shoot those ping.
That's not great if you're in PvP. He doesn't shoot Benoit, but if he did, I would be very curious what would happen. This does not seem like a great PvP experience, but it is probably better than a 30K.
But the world is really in a frozen state right now. But I didn't disconnect, because I'm connected to the replication layer and not to the server anymore. In the meantime, I'm just starting a new server. Let's be a bit patient.
Oh, interesting. So the replication layer is actually sitting. The graph from the CitizenCon presentation from a couple years ago there's sort of the global entity graph up here. There's the replication layer sitting here, and then the game servers are sitting sort of over here off to the side, responsible for updating the world state as represented by the replication layer. And so there's this sort of T shape. And so the replication layer is basically existing as a cache between these.
For it. Should come back online in a second. And as you can see, now that the server came back, it restored the state. It restored the state, and the simulation just continues to work as before. So this will be, again, this is very early tech, but this is a great benefit of what we have with our replication layer split. But there's one more thing. And let's try this thing again. I just killed my server, and I'm trying to do that again. But this time, we're doing something different. So let's first go in here. This is my development tool. I can talk about it in a second. So let's stop that server again. And restart. And this will take a little bit. I'm running this tool you see here. This is our internal development tool. This tool runs the entire stack of our game on this PC.
Mm-hmm. Yeah, there we go.
This is obviously for development only, and I can do that with my small test level. But this really helps online devs and all people who work on the incredible, complicated tech we hear to be able to develop our game.
Yeah.
And because I run everything on this PC, it's a bit slow. So let's wait and see what's happening here.
Just think how slow it'll be when they get 100 people in it.
All right. Simulation continues. I can see Ben moving again. Hey, Ben. However, what just happened? Well, as you can see on my screen, I no longer have one server connected.
Yeah.
I have 3 servers connected to this replication layer. So what you guys see here, this is the very first version of a working server mesh.
Yeah, there we go. Okay. Now, there are 3 game server processes. Each of them has authority for one area, one volume of the game world. Here, there is some process for handing things off between them, which we're going to see and probably talk about in a second. And yeah, I'm guessing here that the replication layer and the graph database in the replication layer are actually serving as sort of that it's, well, okay, it's not a distributed lock server, it's a centralized lock server. Okay. The physics computation, for example, is happening in a distributed fashion on each of the game servers, but they're coordinating that through the shared state of the replication layer graph database. So, okay. Better than having to implement distributed lock service with Paxos. Ask me how I know.
All right. So now I'm going to explain a little bit how this magic works, because it is truly magic.
Or a rig demo.
Each server, when it came up,
I mean, it's both. It can be both.
And the replication layer realized there are 3 servers. We assigned different zones to those servers. And we said, okay, server 1, you are the authority over the purple area. Server 2, you are the authority over the green area. And the last server is authoritative over the red area. You can still see that those servers have all those entities replicated, but only the entities within their zone are actually authoritative on that server. So while I'm in this green zone at the moment, my entity is simulated on that green server and just replicated on the other server.
Because the data is getting shared through the replication layer, that sort of central right replica of the full persistence graph database.
And now,
and presumably both each of these servers is subscribing to updates from those zones from the replication layer, as well as the game clients are getting updates from those zones in the replication layer. We'll probably get to that in a sec.
as I transition between those zones, you will see that on that green server, I just lost authority, and on that purple server, I just gained authority.
Right. There's some mechanism in the server code to understand these transitions. The data base, like the database is handling that, is serving as sort of the lock server, but this game server still has to understand, okay, in this frame at this tick, this entity is transitioning from my zone of control to some other server's zone of control, and there's a handoff process there. That boundary, existing on that boundary, is also going to be interesting. I wonder if they transition control when the entity is fully out, or when the entity begins to leave, or how they're handling that. That's, going to be interesting.
And because my player was replicated on both servers, this...
Right, the data, so, yeah, both game servers had the data, the requisite data, and so at least the authority handoff was a matter of just games server 1 saying probably to the replication layer, all right, game server 2 has the con now. Game server 2 being like, okay, I have the con confirmed. Game server 1 being like, okay, game server 2 has confirmed. Game server 2 has the con. Game server 2 has authority for this entity. It's, a sort of three-phase handoff would be what I'm guessing they're doing there. That's tricky. Not by no means impossible, but by no means particularly novel, but tricky. Important to get right. Very interesting. Okay.
Completely works seamless. And again, let's do that a couple of times. You see on my client here, I don't notice anything of that.
This is because this is all running locally on the guy's laptop. Like, that's why he doesn't notice anything. If this were running on game servers and replication layer, servers that are living in whatever cloud it is that CIG is using for this, then that is a much harder problem. The latency of these handoffs matters a lot, and so it's very important that both the sort of game server processes and the replication layer process be tightly co-located. It's entirely possible that these are all going to be running as Kubernetes pods on a single physical machine. These days, our physical machines get big enough that that's totally possible. And my understanding is that these game server processes are surprisingly small. So that is one way that they might crack this latency problem and achieve something similar to sort of laptop level latencies. But this is one of the rigged parts of the rigged demo, that the reason he doesn't experience substantial latency is because, these things are not talking through a wire, and network cards to other physical computers. They're all passing packets around inside the memory of the computer.
Yeah, this all happens behind the scene, and this doesn't work only on me. Let's turn on the zone colors and the object, the authority assignment on the client as well. You can see that even entities, as they transition into the other zone, seamlessly transition to that zone. And not only that, I can also interact with entities that are on the other side. So if I go on the screen zone, for example, and I shoot this, I can still shoot.
So this is the part that I found the most impressive. And I don't know if this works because bullets are physicalized. I don't see the little box around the bullet. I guess I can back up a sec. And we
Other
can...
side.
Oop. Okay, I don't see any little, mesh cube around that bullet, although it's possible it's there and it's just too small, or they decided not to draw it in the representation or whatever. So it's possible that bullets are physicalized and that's how they work. And it's also possible that there's some clever tech going on. I would bet more that bullets are actually physicalized, and we can't see the graph database here, for example, to see if, like, imagine a machine gun, for example, spawning all those bullets as graph entities and replicating them, and then that sounds challenging. That sounds, yeah. Not impossible, again. And I haven't looked at like how the netcode for the game works, and yeah, I have no idea. But this is the part, like, this ability to interact across server authority boundaries. This is the part. This is the magic.
I shoot this. I can still shoot that purple entity.
Yes.
And I can also just go ahead and destroy that buggy which sits on that other zone. There you go. Always fun to blow stuff up, right?
Oh yeah. Especially in distributed systems.
So there's more to this. The first thing I will do, let's spawn a fresh buggy. I just destroyed my old one. When I go into this buggy, I will become part of the aggregate, and that means that now my buggy and myself will transition authority together.
And this is the strength of that abstraction, that graph abstraction, right? Like, the player is just a node with a collection of children. The buggy is just a collection of... It's just a node with a collection of children. If one of the nodes in the buggy is a driver's seat and the player gets attached to that node, then when the buggy moves from server to server, the player moves from server to server. Like, this is the reason that it is not entirely ridiculous for CIG to be like, oh, we'll just use graph databases for everything. I mean, that'll just solve this problem, right?
This is how we make sure that my player, while he's driving this buggy, is always authoritative on the same server. So you can see, as I drive around with this buggy between the zones, I will switch between the different servers. All right. But there's more to this.
It occurs to me, and maybe he's going to get to this in just a sec, but it occurs to me that maybe the reason that it is so hard to interact from this sort of like purple zone to this sort of red zone is not because of the server tick rate, but because not all of the entities over here are streamed in over here. Not all of the data is there, except all the data is here, at least in this demo. So no, ignore me. Never mind. I think that's wrong. I think that the server tick rate is a more plausible explanation there.
So remember when I turned on the streaming earlier? The same streaming mechanics work here as well. Like, obviously in this example right now, you can see all those servers, they have all those entities replicated. And it's a little bit wasteful because you have 3 servers, all need to replicate all those entities.
Sure.
And that's where streaming come into play. I can turn on streaming here, and you will see that suddenly...
Okay, now, here we go. Maybe I was actually right.
My purple server no longer has the red area streamed in. And the red server no longer has the purple area streamed in.
And so imagine if these were all in one straight line, if you shot a bullet from the purple area at something in the red area, and the server in the middle would have the data streamed in, but it's not authoritative for the interaction between the bullet and the object, and the purple server doesn't have the object streamed in, although the player can see it. I'm not sure quite how that works.
So let's see what's happened when I drive my buggy backwards into that red, into the red zone. What happens on that purple server? And I just disappear. So right
the purple server just garbage collected you.
now on this server, there's only Benoit replicated. And Benoit, if you come to me over in the red area, you will see that now on this server, there's no client at all.
Right, he also gets, they say streamed out, he also gets garbage collected.
And
Doesn't that sound ominous?
in theory, we could now completely stream out the entire area on that server, or stream in a new area. And you will also see, as I drive back into the green area, I will magically reappear on that purple server. And this obviously works on the other side as well.
I think this is being mediated by the replication layer, meaning that the data is getting streamed back in from the replication layer to the server. But like, if the servers are memory constrained, which it seems like they might be, then being able to only hold in memory the things that you need to hold in memory, you know, the things that you're responsible for, that you have authority for, and any adjacent regions, and then let the replication layer be, you know, keep in memory the whole world state of, I think they call it the shard, that all of these game servers are collaborating to create, seems like a valuable abstraction. And that, like, so obviously the replication layer needs to be very memory, like, needs to have a lot of memory, but the individual game server processes, which are running the simulation for their bits of the world, can be very CPU heavy, but don't need to have a ton of memory. So that seems like the trade-off they're trying to make here.
Let's get a couple more player join. I have a couple more QA in the back, so you can just see the whole thing running in live with a bit more things going on. Let me get out of this buggy. And you will see on each server renderer which clients are currently replicated on those servers and which clients are actually authoritative on those servers. And you can see this, the green server, because it's the middle one, has most entities replicated. And then you can see this purple one at the moment only has one client replicated. Yeah. So yes, this is pretty much it.
I guess I said that the latency between these servers matters, and it does. But the other thing is that careful design of the protocol between these servers can mitigate some of that, where like the servers don't need to communicate directly, they just communicate through the replication layer. And as long as, you know, also we have the advantage here that they're all running the same code, for example, like, right, like you don't have to deal with a world where like, you know, you're deploying something, you know, you're deploying a server that has a bunch of mobile devices talking with it, which are running like 10 different versions of your app. And so over the, you know, and it might take people, you know, 6 months or a year to get off the oldest version of the app, unless you like particularly force them off it. And so you have to support older versions. The nice thing here is that all of the game servers here, which are running individual zones, are all running the same code. Excuse me. And so assuming that you have designed them thoughtfully, you can sort of assume that each of them will make the same kinds of modifications to, entities in motion that the other ones will, and so all that matters is really that two of them aren't trying to modify, make changes to the same entity once, like update its position, for example, as it moves. And so that's a strength. That is probably also part of why they're able to get away with this. And again, because they don't have to do this coordination directly, they can do this coordination via the entity graph, and basically just by like who's got authority for which object container for which zone, and what's in the zone that they have authority for.
It. I hope.
Sorry, what's in the zone that they have authority for, and the adjacent zones, because so that they can easily go. They don't have to, wait for the persistence layer rather to like hand them the data representing the buggy when the buggy crosses from one to the other. It's just a simple matter of like, oh, they get the notification from the entity or from the persistence layer rather that now they're the authority for this thing. Although still, again, the atomics on that are like non-trivial.
Hope you guys
making that atomic is non-trivial.
Guys enjoyed this. It has been a long time to come to this point, and I just can't put in words how much tech and work we had to put into this. Big shout outs to the network team. Big shout outs to the online services team.
Oh my god, yeah.
Big shout outs to Chris to let us doing this.
For making you do this, but he's at least also paying you, I hope. Well, so,
It's been a really long journey to get to this point, and I've got to say the team has done an amazing job. They've been working diligently for the last 4 or 5 years. We've had a couple of false starts. We finally have an incredible, the way the replication layer works and how we can spin up servers and down and keep the state constant, even if a server goes down, is, I think, a genius design. And the first time I saw this, about 3 weeks ago, working fully, I cried. It's like giving birth. We did it!
You don't have all the pain. I'm sorry, guy. But yeah, no, seriously. It's a big deal. I'm very impressed. Yeah. Bravo, bravo, bravo.
And we wouldn't have been able to do this and work on this kind of tech without all your support.
That's right. 100%.
All our pathological willingness to continue believing in this guy and his team, our wild-eyed optimism, our holding the line. Yep. This is not something a AAA publisher would have put up with at all, and this is not something a smaller publisher could have afforded. So yeah.
Guys,
and your trust,
allowing us to take the time to do it right, to really build it. So thank you
guys
so much for everyone, and thank you everyone at CIG that's really worked hard to deliver all this amazing stuff that will be either in your hands now or in your hands very soon. And this is just the beginning of CitizenCon. We got a lot more stuff to show you.
Yeah. That's what we need for this MMO, guys. That's what we need.
Great demo, by the way.
I guess I said in a previous version of this video that I didn't think they let the backend people out even for good behavior, but I guess this guy did get let out for good behavior. So if I had been at CitizenCon, I could have talked with him. But okay. So we got to go back. There's one thing, and it's really important, and it gets at the heart of like what makes online gaming hard, and also what makes online gaming interesting. Where was that? Where was him shooting across the boundary? It was in here somewhere. I can see that I've been recording for 1 hour and 10 minutes already, and like I might just again yeet this up onto YouTube, and yeah. I'm sorry. No, here we go. Come on, come on, come on, come on, come on. Is this him? Is this it? Okay, yeah, sure. This'll do. Okay, so this is a really important principle in online game design, it turns out. If you shoot somebody, who decides whether they got shot or not? This is not kind of a trick. Is it a trick question? I don't know. It's kind of a trick question. It's not really a trick question. The answer, it turns out, is the shooter calls the shot. The shooter determines whether the shot hit or not, because Blizzard actually has a great presentation on this. They talk about the design of Overwatch, the original Overwatch, and how they did the network stack for Overwatch, and that was the thing that they said, is they decided, like, it's really, imagine you're playing Widowmaker in Overwatch, for example, the sniper, and you've got the perfect position, and the enemy's, the enemy's tank just, like, waltzes straight into your sights. The crosshair is on their head. You press the button, and nothing happens. Right? Doesn't that suck? Doesn't that feel shitty? That your whole job is clicking heads, and you clicked that head and it didn't explode. Like, and from 1,000 prior matches that by all rights it should have. Like, that's a shitty feeling. And so it turns out that in online gaming, the server is authoritative on this, obviously, but the server's authority is designed around, unless the client is misbehaving in some particular, in some particularly egregious way, the client is operating normally. The client of that Widowmaker player is like, yes, that shot should have connected. The server is like, yep, based on my understanding of the world, that shot should have. Based on my understanding of your understanding of the world, that shot should have connected. I can confirm that shot connected, whether or not the client, it's sort of immaterial what the client of the Roadhog player thinks. Ideally, the client of the Roadhog player is also like, yeah, you got me, boss. But you got me dead to rights. But even if not, it's more important that the offensive player connect when they believe they should have connected. And it turns out there's like an underlying distributed systems principle there. A friend of mine, a guy named Jake Beal, who's now, I don't know what Jake is doing. He was a PhD candidate at MIT when I was there. He was involved with the LARP group at MIT, because that's the kind of nerd that we both were. And he did a presentation on what it was called. The LARP group at MIT was called the Assassin's Guild. And so we did a lot of like high action games, which may also surprise you, but it's true. And a lot of games that involve toy guns. And it was a basic principle of the way that we ran games that the shooter called the shot. And so he has this paper, which I'll link in the description, that I don't remember what he did it for. He presented it to us in the guild, and then he also presumably published it somewhere, I don't remember, about like what the distributed computation that we did to play a LARP, and all agree on, like, if I shoot the monster, walking down the hall at me, like, how do we decide when the monster goes down? Like, shooter calls the shot. I don't know how CIG here are, like, exactly implementing shooting across server boundaries, but I do 100% know that this server, the purple server, is authoritative for whether this shot hits the buggy or not. And that may also be why there's this dogleg here, why you cannot shoot from the purple server to the red server, because the purple server can only be authoritative for the shots into the server next to it. Like, yeah, that's what I got for you. There will be a bunch of links in the description below to this video, Jake, my friend's paper, the Blizzard talk on the Overwatch netcode, and the something else I was going to link. I hope it comes to me in the edit, but yes, this has been A Software Engineer Reacts to the Future of StarEngine panel at CitizenCon 2953, specifically the bit on persistent entity streaming replication layer server meshing. This has been your server meshing video from me. If you have questions, which I can only imagine that you do, because I also have a lot of questions, please leave them in the comments below, and I will do my best. Or we will muddle through and try to figure them out together, because I got a lot of great comments in the last video. Really appreciated that. And yeah, I don't know if I will do more of these. I presume that CIG will continue talking about this. I am looking forward to the moment when it launches. If they do an even deeper dive into this, I will definitely be there, and if anyone from the server team would be interested to do an interview with me, I'm just saying, my contact info is on my website, which I'll also put in the description, just in case. Because, again, I am fascinated by this. I love talking about this. I would love to, like, have a conversation with somebody. I was really sad not to make it to CitizenCon and try to corner somebody in a bar to get some answers. Assuming, again, that they let the back-end folks out for good behavior. So, yeah. That's what I got. Hope you enjoyed it. Yeah. Till next time, folks. See you in the verse.